In our unit of solving systems of equations, we've looked at two methods already. We've looked at graphing and we've looked at substitution. Today we're going to look at a third way to solve these systems, and this is solving by elimination. In order to start the system solving systems by elimination, you'll again have your two equations with your two variables, x and y, and the first thing you want to do is look at your equations and decide how you can multiply one or both of the equations so we get the same number but with opposite signs as the coefficients of one of our variables. Now this can work with x or y, it doesn't matter as long as you're finding the one that's going to be the easiest for you. The second thing that we're going to do is add the equations together. And that's why it was very important for us to get the same number with opposite signs. So when we add the equations together, that variable cancels. Because remember, it's we cannot solve two systems of equations with two variables. We have to get it down to be one variable. And after we have it down to that one variable, then we're going to solve for that variable. And what I mean by solve for the variable is get x equals some number or y equals some number, depending on which variable you're left with. It'll be different for different problems. The fourth thing we're going to do is take that value and plug it into one of the equations to solve for the other variable. Then we'll have our ordered pair. And then just as we did in substitution, you need to make sure, this one you'll get the other one. So if you had x equals a number on step 3, then on this one you'll get y equals a number, or if you had y equals on step 3, on that one you'll get x equals. And then again, just like in substitution, we need to write our answer as an ordered pair. So let's try an example of this. First example we're going to look at, again we're going to draw our little curly Q that reminds us that this is a system of equations. And our first equation is 4x plus 3y equals 0. Our second equation is 5x minus 3y equals 27. So we look closely at the two numbers in front of x and the two numbers in front of y. You'll notice 4 and 5 are not the same number, but 3 and 3, that's the same number. And notice it's already got our signs here, so step 1 has already been completed for us. The equations already have the same number but with opposite signs in front of one variable. So we skip on to step 2. We're going to add these equations together. When we add these equations together, we are going to get 9x. Notice our y's cancel, and that's the whole purpose of that step 1, is to cancel those y's. Or cancel whichever variable, it's not always going to be y. So then we go ahead and solve for x, and we get x equals 3. That was step 2. Nope, sorry, that was step 3. Now for step 4, we're going to plug that back in, and it doesn't matter which equation you choose. So I'm just going to put it back in for the top one. So 4 times 3 plus 3y needs to give me 0. Oops. There we go. So when I multiply, I get 12 plus 3y equals 0, and then I just continue to solve, remembering to add or subtract my numbers over before I divide. So in this case, y is negative 4. And remember, I don't have an answer yet because I have to write it as an ordered pair. So this is my answer. That was solving by elimination, and we can always check ourselves using a graph. So I'm going to show you the two methods we've got for graphing. Here's my system. Remember, the two methods for graphing are you can get y by itself and graph in slope-intercept form. So for my blue equation, 4x plus 3y equals 0, I'm going to do that. So I'm going to subtract the 4x over, and 3y equals negative 4x plus 0, so I don't really need to have that. Divide by 3, so y equals negative 4/3 x. Now notice there's not anything there, which means my y-intercept is 0. So I can put the plus 0 there if I would like to. So on my y-axis, I'm going to find 0, and that's my first point. Then I'm going to use the slope of negative 4/3 to graph other points. So I'm going to go down 4 and to the right 3. And I'm going to repeat this until I've got 3 points on my graph. Then I'm going to use a straight edge, and since I don't have a ruler handy, I'm just going to use a piece of paper. So I've got my paper, line it up on all 3 points, and draw in a super straight line. Remember that accuracy and precision is important, because if we are off even by just a little bit, it won't show where our equations intersect, and then we won't be able to see our solution. So that was graphing in slope-intercept form. The other way we have to do this is by the cover-up method. In the cover-up method, we first cover up one of the variables. In this case, I'm going to cover up the y, and my equation now says 5x equals 27. If I divide by 5, I get 27 divided by 5 is 5.4. To write this as an ordered pair, since I covered up y, the y is 0. And this says x equals 5.4, so I'm going to put the 5.4 in for x. Then on the next, to graph the other intercept, I cover up the x, and it's negative 3y equals 27 is what I've got left. If I divide by negative 3, I find out that y is negative 9. In order to write this as an ordered pair, I put the 0 first because I have my x covered up, and negative 9 as my y value. So to go to 5.4, I'm going to go to graph that. I'm going to go in between 5 and 6, about halfway, just under halfway, and then 0, negative 9 would be right and left 0, and down 9. Again, since I don't have a straight edge here handy, I'm going to use my handy dandy paper and draw in a super straight line, and then double check that my graph did indeed intersect at the point 3, negative 4. It looks like I did, so I'm very excited that we've done this one right. Let's try another example. In the second example, we're not going to be given the numbers lining up just perfectly. We're going to actually have to do some multiplication. So 4x, let me get that one off there so we're not getting confused. 4x plus 3y equals 19 is going to be our first equation, and our second one is 7x minus 6y equals negative 23. If we look closely at 4 and 7, those are not the same. I couldn't multiply 4 by something to get 7, so I probably don't want to use those two. So I'm going to look at my next two, 3 and 6. Oh, I can multiply 3 by 2 and get 6, and notice they're already opposite signs. So that's what I'm going to do. I'm going to multiply this top one by 2 and put it over here, and I'm going to bring the bottom one just over. So bringing the bottom one over stays the same. Multiplying that top one by 2, 4x times 2 is 8x, 3y times 2 is 6y, and 19 times 2 is 38. Now just in case, if you didn't have anything handy dandy like that where you could just multiply one by a number and get the other one, you can always take these numbers and reverse them. So like multiply the top equation by 7 and multiply the bottom equation by 4. Then these numbers would match up. Remember also that you need one of them to be negative, and since these are both positive, you'd go ahead and multiply one of these by the negative. So like this would be multiplied by -7 and this by +4, or vice versa, it doesn't matter. But you can always take these numbers and just switch them. So I'd multiply the bottom equation by 4 and the top equation by 7. That will always work if you don't want to take the time to sit here and discover the easiest way to go about this. But believe me, you're going to want to try to do that easiest way because it is going to give you smaller numbers in the end. So now on to step 2, which is add the equations together. 8x plus 7x is 15x. My y's cancel. And 38 minus 23 is going to give me 15. Then I have 15x equals 15, divide by 15, and I'm going to get that x equals 1. Then again, I have part of my answer, so I'm going to plug it back in to one of the equations for x. It doesn't matter which one, so I'm just going to choose this bottom one. So 7 times 1 minus 6y equals -23. So 7 minus 6y equals -23. You need to subtract 7 here. -6y equals -30. And we'll divide by -6 to get y by itself, and y gives us 5. Again, we need to write this as an ordered pair. So it is 1, 5. And if we would like to check by graphing, we certainly can do that. We don't have a graph set up, so we need just a second to get one on here. Okay, so we had our 4x plus 3y equals 19, and we had 7x minus 6y equals -23. If we do this by the cover-up method, if I cover up the 3y, the ordered pair, 19 divided by 4 is 4.75, so 4.750. And when I cover up the y, 19 divided by 3 is 6.3 repeating. To do the cover-up method down here, if I cover up the y, -23 divided by 7 is -3.29 approximately. And if I cover up the 7, -23 divided by -6 is 3.83. And I already had those calculated, so don't think I'm like a major math whiz. Oops. My line drawing skills are not in fine form today. So to graph 4.75, I'm going to go here almost to 5, and then to graph 0, 6.3, up there. And again, using a piece of paper as a straight edge, I'm going to connect those. Make sure to draw your line quite a bit out, and then, okay, my next one, -3.29 and 3.83. Oops. And we will connect those with a nice straight line. Make sure we drew it very long. And look, voila! Our graphs checked what our algebraic answer was and confirmed that we are right, that these lines do in fact intersect at 1, 5. That was Solving Systems of Equations by Elimination.